Okay, guys, this is going to be lesson 63. With lesson 63, we are going to be adding vectors. Okay, so remember our coordinate planes that we had with the negative r and the u, the positive r and the u, negative r, negative u, and r, negative u. Remember that? Okay, and then remember we had our coordinate, so this was our rectangular form, and then our polar form, say if I had this line right here, and I'm looking at this dot, okay, the location of this dot, say this is 4 units of measure there, and this is 57 degrees here, and they would have given this to us as 4 and 57 degrees. Okay, so that's what that would have wound up looking like. Say if we had another one that was 7 and 230 degrees, all right, that would look like this. We'd take the 180 degrees around and we'd come on down here, we'd be left with 50 degrees, and this right here is 7 units long. All right, so what we're going to look at now, these over here are going to be my vectors, and if I'm going to add my vectors, what if I do if I've got 2 of them and I want to add them together? Okay, all right, so we're going to look at having a guy, and we're going to say that he traveled 20 miles at 20 degrees, and then after that, he then traveled 40 miles at 210 degrees. All right. So this right here, we would potentially be given, this is going to be, this 20 and 20 degrees. This right here is 40 and 210 degrees, just putting it in the form that you're used to. All right, so let's work with both of these. So what I'm going to need to do, and so I need to add these two together to find out where he lands up. In order to add these, I need to put them in rectangular form. All right, so let's get this into rectangular form here. So drawing myself a picture, I have, this, I've got this, I see that this is going to be 20 degrees, this is going to be 20 units, and we can think about, this over here, this is how far east he went, and this is how far north he went, and, he landed right there, okay? The east is the adjacent side of my triangle, the north is the opposite side of my triangle. Okay, so here I have the hypotenuse that I'm looking to solve for the opposite and the adjacent, so I'm going to be able to use SOHCAHTOA. Okay, so here, remember my SO and my CA. Okay, so what I've got here is that the sine of a 20-degree angle is going to be equal to n over 20, and the cosine of a 20-degree angle is going to be equal to E over 20. All right, so if I calculate that, I'm going to find here that N equals 20 times 0.34. So this 20 is going to equal 6.8. All right, the E is going to be 20 times 0.94, and I got these numbers right here. This right here is by entering the cosine of 20 in my calculator. This number right here is the sine of 20 in my calculator. Okay, so when I do these two, I get 18.8. Okay, now notice this 6.8 is north, so this is 6.8 up. This 18.8 is how far east I went, so this is 18.8 right. All right, now let's look at this triangle over here, okay? And here I've got, this, it's 210 degrees, so we're going to have, 180, and then 30 more degrees is down this direction, and the length of this is 40 to get to that point out there. So here I'm solving for this, okay? And I'm looking, he went so far west and he went so far south, right? So again, it's going to be the adjacent and the opposite sides of my triangle that I'm looking for. So here I see the sine of, this time it's 30 degrees, the sine of 30 degrees equals how far south he went divided by 40, and the cosine of 30 degrees equals how far west he went divided by 40. All right, so I wind up with that getting up here, this is going to be 40 times 0.5 is going to give me 20. And here is going to be 40 times 0.87 is going to give me 34.8. Okay, remember this right here, I got that when I entered into my calculator the cosine of 30. Okay, so this 20 right here, this 20 represents how far south he went. Okay, remember, so south is negative up, all right? And the west, this right here, this is how much west he went, so this is negative r. Okay, so I'm going to put these things together. So I can come over here and I'm going to have 18.8 r and 6.8 u. And then I have negative 34.8 r, and I have a negative 20 u. And now I just combine those two. So when I combine those two, I find negative 16 r and negative 13.2 u. So this is the answer. So when I combine 20 at 20 degrees plus 40 at 210 degrees, I get this right here. Okay, so that's going to show me where he was when all is said and done. You know, if I were to take and plot that point, if I had an actual piece of graph paper, you know, all done to scale and everything, I would come over, you know, 16 units here, and I would come down here, 13.2 units, and I would find a point right there, and that would be where he landed up. Okay, so that's how the addition of those vectors goes. All right, let's look at another one real quick. Okay, if I've got 30 at 55 degrees plus 10 at 170 degrees. All right, so we're starting with that. This one over here, okay, I've got this, I have 55 degrees, and I have 30, okay? And I have so far that I'm going east and so far that I'm going north, all right? And this one right here, I've got that. Okay, here, look at this one. This one's going to be different. I have this 170 degrees right here. So this is important. There's that 170 degrees. Here's going to be a little 10 degrees right here. This process that we go through works with a right triangle. So I'm going to have to work with this triangle that I create with this remaining 10 degrees there. I'm not working with that 170 degrees over there. Okay. So this is going to be this 10 degrees here, and my length over there is going to be 10. Okay, and with this right here, he's going to have traveled some distance north, and he's traveled some distance west. All right, so over here, I'm going to use the sine of my 55 degrees is going to equal however far, you know, the north is over my 30 for my hypotenuse. Okay, so north equals, when I calculate all that out, I'm going to get 24.5746. All right, over here for this one, I've got that the cosine of 55 equals however far he went east over the 30. Okay. So when I calculate that out, I'm going to get that east equals 17.2073. Okay, remember that this is going to be right and this is going to be up. All right, so I'm going to come over here now and look at this other one. Okay, remember I'm dealing with this little bit of a triangle that's left right over here, this little 10-degree triangle. All right, so now the distance that he goes north is going to be equal to the sine of 10 degrees. All right, and that's going to equal the north over 10. Okay, so I wind up doing 10 times the sine of 10 is going to equal my n. All right, and so my n right here is going to equal 1.7365 u. Okay, when I'm looking at how far west did he go, west is going to equal the sine of 10 degrees. All right, and however far west he went over, not over west, over 10. Okay, so when I kept winding up calculating that out, I'm going to do 10 times the cosine of 10 is going to give me my west. And so my west right here is going to wind up equaling 9.8481. And that's going to be a negative r. So now all I do is go and combine those two things together. 17.2073 r, 24.5746 u. And then I have the negative 9.8481 r and the 17.2073 u. So when I combine those two together, I get a 7.3592 r, and I get a 26.3111 u. Okay, and I can, of course, round these, to where this could be a 7.36 r, and this is going to be a 26.31 u. Okay, so as I put that together then, thinking about this, all right, so this is going to come over a distance of 7.36, all right, and it's going to go up a distance of 26.31, all right. So I know that's there, I know this is here. I don't know my hypotenuse. So I need to figure out what is my hypotenuse. All right, for figuring out our hypotenuse, we are able to just use the Pythagorean theorem. Remember that h squared equals 26.31 squared plus 7.36 squared. A squared plus b squared equals c squared. All right, so if we take the square root of all that, we're going to get that h squared equals the square root of 26.31 squared plus 7.36 squared. So you just do that math and you get that your hypotenuse equals 27.32. Okay? All right, so now I know my hypotenuse length right here is going to be 27.32. All right, with that, okay, I've got these things. What I don't have right now, still though, now is this angle, if I'm looking to find everything that I need there. All right, so now as I'm going to solve for the angle, okay, here I was solving right here for the hypotenuse. And this right here gave me the two sides. All right, so that's how I found the two legs. This is how I found the hypotenuse, and then now we're going to look at the angle. So let's say that we consider the tangent of theta. This angle right here we're going to call theta. We don't know what that angle is right now. So that looking at the tangent of whatever that angle is, remember with our tangent we have we're going to with the tangent, we have the opposite over the adjacent. So my opposite side is 26.31. My adjacent side is 7.36. All right, and so here, remember, I can go ahead and do this math right here. I've got the tangent of some angle is going to equal 3.575, and this is where you need to, in your calculator, use the inverse tangent. All right, you might have to hit the shift key or the second key before you hit the tangent button. And so you use that to calculate, and you find that this right here is going to equal 74.37. So that's what that angle right there, this angle now is going to be 74.37. All right, so look at now I've got a better picture of this. I see the fact that it's going to be over 7.36. Okay, I'm going to have, this is going to come up here. My angle is going to be 74.37 degrees. The length right here is going to be 27.32, right? So the way I could write this now back in the polar form is going to be 27.32 and 74.37 degrees. Okay, remember I started off with adding these two right here. So when I add this 30 and 55 degrees and the 10 and the 170 degrees, I come down to getting 27.32 and 74.37 degrees. All right, so this is a bit. These problems, there's a lot to them. It's not bad, but it's a lot. So, okay, when I've got this right here, when you get this problem, and you're asked to do that, I need to take the first vector and I put it in polar form. So then I wind up finding the u and the r. I take the second vector, I put it in polar form, and I get the u and the r. Okay, and I add those together. All right, so now I've got this, combined triangle that I'm starting to make. And so over here on my triangle, I'm able to do the, the side going east. I'm able to do the side going north, but I don't know my hypotenuse and I don't know the angle yet, okay? Where I have the two legs, I'm able to then use the hypotenuse, I'm able to use the Pythagorean theorem in order to figure out my hypotenuse. All right, a squared plus b squared equals c squared. All right, then once I've got my hypotenuse, now I know all three sides of my triangle. This over here is the 26.31. I know all three sides of my triangle, so I can use my tangent in order to figure out what that angle is right there. I've got these two. You could actually use any of them. You could use sine, cosine, or tangent because you know all the sides. All right, but I just chose to use tangent, and I'm able to take and divide the two sides to find out what the tangent is, but I don't know the angle, so I have to use inverse tangent in order to find out what is that angle, and that angle is 74.37. So these problems are big. There is a lot to them, but if you just take it one step at a time, you're going to be fine. You can do this.